My models on the side board use the variable x. Do I have to use x? No. A, A. This one uses B's. But it's still following the same pattern. Whatever's here is the same as here. Attach a radical 2, you've got the hypotenuse. So in number 1, what is x? 5. Put slash marks. If you've got 45, 45, you should have 5 and 5. So what is my hypotenuse? 5 radical 2. A lot of the problems are as simple as that. We're just using a shortcut rather than using the Pythagorean theorem. Could you do the Pythagorean theorem with the 5 and the 5? And eventually you'd get to 5 radical 2. Second one. This is a pattern that I really didn't show on the side board. It's based off of that pattern. You can memorize as many patterns as you want. I'm trying to make it simple by showing you the main two over there. But this kind of follows or looks like what's down here. This time your legs of your triangle have a radical involved. You're still attaching a radical 2. So I'm taking this, the same way I took the 5 and attached a radical 2, I'm taking this and attaching a radical 2. But what's a radical 2 times itself? Just 2, so this is 3 times 2, which is just 6. So in this pattern, you end up with the radicals here, and the radical disappears, and you end up with a 6. That's what's being shown up here, that whatever is in front of the radical in the leg ends up being twice that number. So that little b turns into that. How you want to remember this is up to you. Could you do the Pythagorean theorem with 3 radical 2 and 3 radical 2 and do a squared plus b squared equals c squared and go through that process? Yes, you'd end up with 6. So you can always fall back on the Pythagorean theorem with the 45 45s. So if I'm looking at number 3, I'm thinking to myself, that's a weird looking leg, but I know that this side is going to be the same weird looking radical. And what do I need to attach to it? A radical 2. So I'm taking whatever that is, it just happens to be 5 radical 6, and I'm attaching a radical 2 to it. That gives me 5 radical 12, which you will not see as an answer because that's not in the simplified radical form. How can I change radical 12 into something useful? Factor it into 4 squared. So I got a 5 still. I got a radical 4, then a 3, so that's 5 times 2 times radical 3. So all of this ends up being 10 radical 3 in that spot. You can end up with a variety of radicals, fractions, decimals. Whatever happens, happens. Some people think it's got to show up with a radical 2 in there. Well, it doesn't. You're attaching a radical 2, and then whatever happens, happens. The same over here. You might see the radical 3, but it might combine with something else. Like this 2 combined with that 6, and that created something else, and that created a 4 and a 3. Whatever happens, happens. But the same general pattern applies. If I'm looking at number 4, I'm thinking of my original layout. I'm seeing a radical that matches perfectly with the pattern. Can everybody see that that's 8 and 8? I'm not seeing a radical, but I know it's there. What will x and y be? 5 radical 2. That's kind of following this secondary pattern. What do you do when radicals show up here? And you can always check your answer. Attach a radical 2 to 5 radical 2, you're going to get a 10. Last one. A little bit more work. Tell me how you would deal with that. How about divides? Basically, that's exactly what you should be thinking. That, we know, comes from this pattern. So whatever the leg is, after I attached a radical 2 to it, somehow it ended up looking like 4 radical 3. But I know it's equal to that. And that's exactly what I'm going to write. It's equal to that pattern. And I used an x because I see an x over here. Whatever the variable is here, I just use that in that equation. How do you get that by itself? You divide by radical 2. 4 radical 3 over 2 is a perfectly, square root of 2, is a perfectly good answer to stick into your calculator, but you're never going to see it on a test because it's not considered to be in good form. What do I do to that? I got to rationalize the denominator. Make the bottom look pretty. 4 radical 6. Radicals times radicals. I get a 2 on the bottom. Can I reduce that at all?
2 radical 6.
2 radical 6. So that's 2 radical 6, and that's 2 radical 6. I could have done that same thing with number 5. I could have made the 10 equal to x radical 2. And after going through the problem, I would have ended up with 5 radical 2. So you can either look for a pattern, or with something like this, you pretty much had to do this. It's hard to see how you get from a radical 3 to a radical 6 without actually rationalizing the denominator. Any questions on those top 6? Today's our review day. Go a little slower. We're good? Second process is 30, 60, 90. For some reason, when we get to this, people think that the radical 3 part of the pattern applies to the hypotenuse because it applied with the radical in the last one on the hypotenuse. But this is the long leg. What did I tell you to focus on or label with the 30, 60, 90? Short side. Look for the 30 and see if you have the short side. I don't have it here. I don't have it here. Do I have it in the last one?
Yes.
Actually makes it an easier problem, I think, if you have the short side, because everything else is based off of it or in terms of the short side. So I'm going to go to the last one first. I'll go to number 9. If I know the short side, what should I do to it to find the hypotenuse? Multiply it by 2. It's like having this, and I want to get to this. Well, that just means I double how many radicals I have. Instead of 5 radical 2s, I have 10 radical 2s. According to this pattern up here, all I'm doing is multiplying by a radical 3, no matter what that is. If it happens to already have a radical, doesn't matter. I'm supposed to attach a radical 3. What does that create? 5 radical 6. You get whatever falls out of it. Done. I got both my sides. Question? These two, I didn't have the short side. Find the hypotenuse. I don't have the hypotenuse. Do I have the hypotenuse here? So this is going to be easier than this, because what's the relationship between hypotenuse and short side? So what's x? 12. Now that I know that, it's just like working my way in this problem. What should I attach? Radical 3. So knowing the short side or the hypotenuse, generally fairly easy to follow the pattern. Over here, we really have the long leg, but this matches up really well with the pattern. Do you see a radical 3? So it's saying, take whatever's in front of it, and that is the short side. So hypotenuse. You can see there's a lot of variations. I could throw in any radical I want, and that's going to create different radicals. So you don't always see the pattern radical in the end. Do you think you can do these problems on the quiz? I think so. Did I get a chance to give you? There was one worksheet with 6 problems on it. Let's take that out. Let's look at that. It says special right triangles. It says 1, 2, 3, 4, 5, 6. So just the front. And it looks like